Okay, sorry for the 12 or so seconds of silence. I'm trying to work out how I can do this example. This comes from the question, I don't know which question it is, it's exercise 1B with the person rowing, and in that they travel upstream downstream. And anyhow, we were told that they go from A to B in, well, this might be the next question actually. Doesn't matter, either way. Yeah, it is the next question. Not the next one, but it's the later one. So A to B at 4 kilometres per hour, and then B to A at 6 kilometres per hour. And then the total journey takes them T equals 45 minutes. Now, this question is difficult. I find them really hard. I've gone through this one a number of times, so I can try and make some sense of it. So I'm explaining it here. Hopefully you guys will be okay to get through it. Okay, now, so what happens is this dude, they're there, they go that way, and then they come back. So they head off slow, they come back faster, and it takes them 45 minutes. Now, what we've got to do, because we're given time here in minutes, we want to convert these to minutes. So we know that 4 kilometres an hour. We know that, we should know, we go to Suzanne Corey, that in an hour is 60 minutes. So this A to B will end up being 4 over 60 kilometres per minute, which ends up being 0.067, and 6 over 60 kilometres per minute ends up being 0.1. So there are our two speeds. So we end up with 0.067 kilometres per minute and 0.1 kilometres per minute. I'm not trying to change it to metres at all. I'm just going to leave it like that because there's enough conversions going on. Now, the other bit of information, so if they're travelling downstream and then they go upstream, that means it has taken them a certain amount of time to go upstream, so that is T1, and it's taken them a certain amount of time to go downstream, and that is T2. And now what we know is that together, T1 plus T2 equal 45. So, and given that they've travelled a distance here, we'll call it D1, and the same distance there, well then D1 equals D2. So that's the information that we're going to use. Now, there's one other piece of information, something that I guess you're expected to know somewhere along the lines, but I don't know, is that speed is a measure of distance over time. And because of that, time is a measure of distance over speed, and also distance is a measure of time speed. And we're going to use that information to try and work out this problem. So now we are going to use this bit of information, this bit of information, and this formula here. So we're going to say that T1 equals D1, which is just the distance, over speed they travelled at T1, which is 0.067, and T2, so as time coming back, is equal to distance 2, which is the same as distance 1, doesn't matter, but it's how we're going to go through it, it's how I did it, is equal over the speed, which is 0.1. And then what we're going to do, we're going to use what we know, these three formulas, and this information to write D in terms of T. So over here, what we're going to do is now we're going to say 0.067 equals D1, and 0.1, or sorry, no, my mistake. Of course it's my mistake, I'm the only one here. 0.067 T1 equals D1, and 0.1 T2 equals D2. So all I've done, I'll just multiply them. So I could write it as D in terms of T. Now, because of this fact, because they're the same, I'm going to let these equal each other. I'm going to equate them. So I'm going to say 0, whoops, I didn't want that. Wrong thing. 0.067 T1 equals 0.1 T2. They equal each other. Okay, so remember, I'm trying to use T1 plus T2 equals 45. Okay, so what I want to do now, I want to write T1 or T2 in terms of the other one. So I am going to divide, I think, hang on a second, just need to check something. I am going to divide both sides by 0.67. So I'm going to have T1. So 0.067, 0.067, and we end up with T1 equals 1.5 T2. So now, what we can do, we can take this thing and rewrite it as, instead of T1, I'm going to write 1.5 T2. So I'm going to say 1.5 T2 plus T2 equals 45. And now, so 2.5 T2 equals 45. So now T2 equals 45 over 2.5. Now, if T2 equals 45 over 2.5, then T2 equals 18 minutes. So now, if T2 equals 18 minutes, we know that he's travelled, or she has travelled 18 minutes at 6 kilometres per hour, or 18 minutes at 0.1 kilometres per minute. So, therefore, after 18 minutes at 0.1 kilometres per minute, he's travelled 1.8 kilometres. So the overall distance will be 3.6 kilometres. So what I'll do, I'll switch over to my other one. Switch over to the other, where I've got all the information. I'll talk you through it again.